Hey guys, welcome back to the channel. So the problem is minimum fuel cost to report to the capital. So let's go through the problem statement. So there is a tree which is a connected undirected graph and it has no cycles. Okay, so it is a tree structure connected country network, okay, which consists of n cities which are numbered from 0 to n minus 1, and these are having exactly n minus 1 roads, okay. Then the capital of this city is 0, okay, so the 0th city is the capital city, and we are given a 2D integer array roads, and in the roads we have a path from the city A to city B, okay, and this is a bidirectional road which connects these two cities, okay, fine. And there is a meeting for the representatives of each city, and the meeting is at the capital city, okay, fine. Then the meeting is at 0 for all the representatives of other cities, and there is a car in each city, okay. So we are given an integer seats that indicates the number of seats in each car, fine. So each city is having a car and the capacity of that car is given by this integer seats, fine. Then the representative can use their car which is present at their city to travel, or they can change the car and ride with another representative, okay, fine. Okay, so the cost of traveling between two cities is 1 liter of fuel, okay. So we can say that whenever we travel through an H, the fuel which is used is 1 liter, okay. And we have to return the minimum number of liters of fuels to reach this capital city, okay. So let's go through this first example. Now here this 0 is the capital city, and these three are other cities, okay. So the seating capacity of each car is 5, fine. So three cars would be present at position 3, 2 and 1, okay. So let's take the first city. So here the representative can travel in that one car and reach at position 0, okay. Similarly, the representative at city 2 would be traveling with his car to city 0, and the same would be the case for this third city. So the total fuel would be 1 liter plus 1 liter plus 1 liter would which would be 3. Okay, so the answer here is 3. Now let's take this example and try to understand the problem much better. So here let's start from this sixth city. Okay, so there would be a car. Let's see the seating capacity here. Okay, so the seating capacity of each car is 2. Okay, so I'll write it here. This is the seating capacity. Okay, so let's take first one car, and that car will travel here. So this 2 will accommodate in that one car, and again the car would be reaching at city 0. So the total fuel used by that car was 2, okay. So from this side we have this 2. Now let's take another car from city 5, and here the car will reach city 0 and the fuel used is 1, okay. So now let's take a car from city 2. So first the car would be going here, the fuel cost is 1. Again, as we have one empty space in our car because only one person is there, this person can accommodate in that same car, okay. So only one car would be traveling here, and the total fuel would be this one plus this one, which would be 2 here, okay. So the car which was coming from here is full now for the representative who is at city 1, okay. So we would take another car. So now we have two cars. The first one is for this representative of city 1, and the second car which would be for these two representatives. So the total fuel would be 2 because we have two cars. So 1 liter for one car and another liter for another car. Okay, so the total fuel would be 2 for coming here, then 2 which was spent here, which is 4 for this complete part, and then 2 from here plus 1 from this part. Okay, so the total fuel would be 4 plus 2 6 plus 1 7. Great. Okay, so let's see what we can do here. Okay, let's say I select the farthest cities. So the three farthest cities here are 2 5 and 6, and I'll just take a car from the farthest city. So first the car would be reaching 4, and now 6 and 4 will accommodate in that car because the seating capacity is 2. So that car would be reaching here, and the fuel cost is 1 plus 1, which would be 2 for this complete path. And now similarly I'll take a car from 5 to 0, and the fuel cost would be 1. Now again from 2 I'll take a car here, and then 2 and 3 accommodates in that car, and then the car reaches here. But as there is no place left for this another representative, the car would be reaching 0 here. So the total fuel cost here is 1 2 and 3. Okay, but now this one is pending, but now the one is remaining to visit 0. So let's take another car, and then 1 will reach to 0, and the fuel spent here is 1. So the total fuel spent is 3 plus 1 plus 2 plus 1, which would be 4 5 6 and 7. Okay, so we can do this, I think. But wait, let's see some more test cases. We have some city like this, and here the seating capacity is, let's say, 3. Now to reach the capital city 0, let's start from this third node again. Now 3 will reach to 1 with his car, and then 1 and 3 will travel together and they'll reach 0. So the total fuel cost here is 1 plus 1, which would be 2. Okay, now 3 and 1 is have reached. Now 3 and 1 have reached 0. Okay, so the fuel cost is 2. Now for 2 again we'll take a car, then 2 will come here, but 1 is already reached 0, so he'll just go to 0. Now here the fuel cost is 1 plus 1, which would be 2. So the total fuel is 2 plus 2, which is 4. But wait, can we do better? Okay, so what optimization did we make here? So what we did here is we stayed at a city until all the members reached at this city, and then we decide what is the number of cars we want from here so that all the members can reach optimally to the capital city. Okay, so what do we need here? At this point we want the number of cars from this route and this route. Okay, so we want the number of cars. What else we want? So we also want how many people are there reaching at this position from any of this road. Okay, so we want members. Okay, so we also want the fuel spent in each of the direction. Okay, so let's say the fuel spent. Now if I know what is the number of cars from this side and what is the number of members from this side and what is the fuel spent from this side, then I can make some calculations at this position. Okay, so I'll write the numbers again. These are the cities. Okay, so the car at this position would be 1, and similarly the number of members would be 1 because 2 is only present, and the amount of fuel spent by all the members to reach this point 2 would be 0 because no member is reaching at this point. Similarly, here for 3, the car is 1, then members are 1, and the fuel spent is 0 because no one is reaching 3. Great. Now the car reaches here, and this car also reaches here. Great. So at this point, the total number of cars is 2, then the total number of members is 2, and then again, what is the fuel spent to reach here by this car and this car. So let's take the car from 2 first. So only one car is coming to 1. Okay, so as only one road is present and one car is present, so the amount of fuel used is 1. Okay, and similarly here again one car is coming and one road is present, so 1 liter of fuel. So the total fuel spent to come here is 2. Also, now we want what is the amount of fuel which was spent to reach 2 and 3. As it was 0, we'll just keep the fuel used as 2 liters. Okay. Now let's again draw the capital city. Then at this point we have two cars, 2 members, and 2 liters of fuels spent to reach here. 2 liters of fuel spent to reach here. Okay. Now at this point, as we have 2 members, but we don't need 2 cars because the seating capacity of each car is 3 as it is mentioned here. So these 3 members can just take one car to reach 0. Okay, so the car will be reduced to 1, and then let's say all the members are present in this car and this car reaches 0. So the total fuel spent to reach 0 is the fuel which was used to reach 1, which was 2, plus the amount of cars which are traveling to 0 into 1 because there is only one road, which would be 1. So the total answer is 3. So 3 liters of fuels is required to reach 0, which is the correct answer. Okay, so let's see the code now. Okay, so let's try to see what are the number of nodes first. Now it is mentioned that we are given n-1 edges, and as there is only single edge between any two nodes, and we have n-1 edges, hence we have just nodes which is n equal to roads dots length plus 1. Okay, then I'll make a adjacency list here to store this graph. And then we'll just fill this with empty list. Okay, now let's store the graph. Now as this is a bidirectional graph, we'll just store the other direction also. Okay, so I'll write 0 here. I'll just correct this. Okay, so we have the graph now. Let's write a DFS function, and in this function we'll just pass the source node, and the source node would be the city. And then what we want is we will pass the adjacency list. We'll make a visited array to keep track of the visited nodes. Okay, then what else do we want? We want the seeds as well, right? Okay, let's write the DFS function, and this function will return the node. And what this node will be having is, let's try to define the node first. Now here we want cars. Then we want the members. What else do we want? We want the fuel used. Okay, so first we'll take cars, then we will take the members, then we will take the fuel. Okay, then we'll just set the cars to cars. So I'll just copy paste this. Then we have the boolean array, which is the visited array, and we have the seats. Okay, mark it as visited. Then we'll just check all the neighboring cities of this source city. So we'll just take the, let's say, neighbor from the city. This is the source city, and then we'll check if we have not visited that city. We have not visited that city, then we'll just visit and calculate our answer. So from each of this side we will get a node. Let's say answer, and the source would be n for this side, and then we will pass the adjacency list, visited city, sorry, visited array, then the seating capacity, right? So initially, let's say the cards are 0, members are 0, and the fuel used is 0. Now from each side we would be getting some cars. So the cars would be cars from here. Fuel used would be, okay, I'll just copy. Fuel used from this part, and then again we have members would be the same. That is members from this path. Okay, so for each of the path we would calculate the total cars, fuel used, and members. Now let's do calculation. So what is the total cars we would be requiring? So the total cars would be how many members are traveling. First of all, let's see the members. Now we'll just take ourselves also, so the members would be increasing by 1. Now the total members divided by seats, so this would give the number of cars we require to accommodate these members. Okay, now let's say some members are remaining, so for them we'll take another car. But how will know the members are remaining? Okay, so we'll just see the remainder to check if any member is remaining. Okay, then if any member is remaining that is not equal to 0, then we'll take another car, else we'll not take any car. Great. So we have the cars, we have the members, and the total fuel would be, here the fuel would be the fuel used by all the places plus cars. Why? Because each of this car would take 1 liter of fuel to reach this place, right? Each of the car from here would take 1 liter of fuel to reach 0, like to reach this path. Okay, so we have members, we have cars, we have the fuel already calculated. Then we'll just return this node. Okay, fine. Then here at the starting node, which is 0th node, we'll just return the fuel used. Okay, so what is the fuel used here? Okay, so everything seems correct. Now let's try to run this code. What I have made. Okay, so int I. Okay, so int I equal to 0. Again, mistake, silly mistakes. Where the semicolon is missing. Okay, I'll just run this again, hopefully it passes. Okay, so it passes all the test cases. I'll just submit this. Okay, so it gets accepted. So thanks for watching and subscribe to the channel for more such videos.